Welcome to the Gridiron Spotlight, your premier podcast for all things NFL. Today, we're gearing up for the 2024 Super Bowl LVIII, a historic showdown taking place in Las Vegas for the first time. The Kansas City Chiefs and the San Francisco 49ers are set to battle it out in what promises to be an epic clash. I'm your host, and joining me today is our NFL analyst, who's here to break down the game's biggest storylines. Great to have you with us.
It's a pleasure to be here. Hosting the Super Bowl in Las Vegas is a milestone for the NFL, adding an extra layer of excitement to this year's game. Both the Chiefs and the 49ers have had remarkable journeys to get here, setting the stage for an unforgettable matchup.
A few weeks ago, Langchain released a new library called LangGraph. Now, according to Langchain, LangGraph is a library for building stateful multi-actor applications using LLMs. The idea is already something you may have seen with tools like AutoGen, and by the way, you can check out my video on AutoGen Studio. I'll leave it in the description. From my perspective anyways, I see LangGraph as orchestrating multiple actions across different states to solve very complex problems. And probably the best way to think about this is to look at it from the perspective of workflow tools or orchestration tools that you may have seen in some enterprise software like Salesforce or AWS step functions. That really is about orchestrating different actions together across multiple states into one cohesive workflow. That's essentially what LangGraph allows you to build. So this gives you a ton of flexibility, of course, when it comes to building these types of applications. So in today's video, I'm going to be illustrating this concept using the example of a workflow that would require these multiple actions to happen. But before we go into that example, I wanted to take a look at some of the key concepts that come with building this type of application. Now, the very first concept is around the idea of a model, and we all know what a model is. A model represents your large language model. Now, the key thing to note here is that for you to get the best results of using a specific model within the LangGraph framework, that model should support function calling. So that would be the likes of OpenAI, GPT 3.5 or GPT-4 or Gemini. And I know there are other open source models that also support function calling, because a lot of what you're going to be doing in LangGraph is either executing as an agent using an LLM or executing a function, which means you need to generate these function arguments that can be used when you are invoking a particular tool or function. Now, the second concept is tools, which is basically what actions you can take, or execute. So this could be search, this could be an API call, it could be a database read and write, or any other actions that you have. Now, typically Langchain comes pre-built with a ton of tools, but you can also build your own custom tools, as you would see in this particular video. The next concept is the concept of a state. Now, a state simply maintains information about the entire workflow and passes it around each step of the flow. So think about it as a log of messages or a log of information about this particular workflow, which can be passed around to give context as to where the state of the flow might be at any given point in time. Now, the most common one which you're going to see in most of the examples is the message state. Now, the message state is going to contain things like your system message, the human message, the AI responses, which can be function call messages or just pure text responses. So it's simply just a log of information that has been sequenced based on how actions have been performed at each stage of the flow. The next concept is the concept of nodes. Nodes represent either an executable function or an agent runnable. So this could be your agent, interacting with a tool, or it could be your agent just simply using the LLM model to generate some sort of text. That represents a node. And I'm going to show you in the example that we're going to be building out what different nodes could look like. So you could have a node that just generates articles. You can have a node that is calling a tool. So there are different nodes that you can build out, and you can build out multiple nodes and then start to connect them using what we call edges. Now, edges basically control how information flows from one node to the other. And there are two main types of edges. There is the conditional edge, which basically looks at specific conditions and decides what to do next. And then you have a normal edge, which always goes back to your agent node or to your LLM to determine what it needs to do next. Now, finally, what you have is a workflow which brings everything together. So this is where your nodes are linked and the order in which they're going to be executed and how they interact with one another. And so those are the key concepts around LangGraph. Now, I know this is sort of a little complex or sounds a little complex, but I think the more you start building out an actual example, the better it becomes for you. And for me, it took me a little bit of time to kind of wrap my head around it. So just doing my best to also convey the things that I've learned from LangGraph and looking at some of the examples they have. I'm going to put a link in the description so you can see some of those examples as well, because it helped me really crystallize and understand it a little bit better. Now, let's jump into our own example. In our example, what we're going to be building out is a workflow that creates a podcast. And if you kind of think about creating a podcast, there are a few things that need to happen. Well, you need to do some sort of research into the topic for the podcast you're creating. There needs to be some sort of recording of audio, and there needs to be some kind of audio mixing because, it's, you need to kind of clean it up and mix it up and sort of produce that, awesome podcast. So we're going to orchestrate this workflow using LangGraph. So first and foremost, I want to walk you through the steps that we are going to be following while building out this particular application. So the very first thing is that the user is going to be sending in the initial command saying, I want to create a podcast about a specific topic. Now, this message will initially be routed to the research agent and node. And the research agent basically has access to a search tool. In our case, we're going to be using Tavily. I really like Tavily because it is purpose built for LLMs. So basically it takes information from the web and constructs it into text that can be passed as context into your LLM to give it the context it needs to answer questions about real world events that is gotten through search. I have a video on creating a research assistant using Tavily. I'm going to drop it in the description so you can check that out if you want to see the full capabilities of Tavily. Now, the next thing that happens once our research agent completes that research task is they're going to be passing their findings over to a podcast planner. Now, the planner is going to be responsible for organizing the podcast flow between the host of the podcast and the guest of the podcast. And what we're going to be getting as an output is a script which kind of sees the host saying something and the guest saying something in response. And we're going to kind of go through that until the script is completely built out. Now, when I tried this initially, I saw that there were some kind of gaps in the way the podcast planner was releasing this script. So I had to add an editor agent who's going to be responsible for approving the content or providing some sort of feedback to review the content before it moves to the next step. So this editor agent is just simply looking at the script, figuring out if the script was written correctly, and if it was written correctly, then it gives its approval, and then we can move it over to an audio mixer agent who then converts all of these sort of fragments of text between the host and the guest into audio and then joins all of them together. Now, keep in mind, because we're using text to speech here, because our audio mix agent is going to essentially have access to text to speech. We're using OpenAI in our use case, and it's using PyDub to kind of combine this. So we need to ensure that each message is represented by the voice of either the guest or the host. So it's very important that we kind of generate it as fragments rather than generating it all as one. So once we're done doing that, then we can combine all of it into one podcast episode, which is the final outcome that is provided to the user. So let's jump into the code and see exactly how to build this out. I have built this in a Collab notebook, which I'm going to be sharing with you in the links in the description, so you can check it out and run it to continue. So let's jump in and see exactly how we're building this out. All right, so to get started, we want to set up our entire environment variables. We're using OpenAI API key. We're using Tavily API key. I'm going to put a link in the description for Tavily. They have a free tier, so you can actually check it out. And I'm also going to be using Langchain API key project and tracing v2 because I want to see the output in Langsmith as well. Now, the next thing we want to do is that we want to immediately install some of these dependencies. So the very first thing we're installing here is LangGraph. We're installing Langchain. We're installing the Langchain OpenAI, Tavily Python, OpenAI, PyDub. Now I'm adding Cohere just because there was a dependency that needed it, but essentially you don't necessarily need it unless you're using that as your large language model. Now, once you're done with the install, the next step is to import, to create some tools. Now, like we said, we're going to be using three main tools here. One of those tools, Tavily Search, is actually a pre-built tool that you can pull from Langchain community tools, Tavily Search. You're going to get the Tavily Search results tool. And there you can pass in how many results or maximum results you want to return back from your Tavily API. Now, I'm going to be creating two custom tools that we're going to be using as well. The first one is a text-to-speech audio tool. And this is basically using OpenAI's text-to-speech function here. And essentially what you're passing in is text and the voice, as well as whatever output file name that you intend to use. So that's what our function is going to be expecting. And we're going to basically call OpenAI and return the audio as required. So this is basically what this tool is doing. The other tool that we're going to need here is our audio mixing tool. And this tool essentially allows us to combine different audio files together into one. And we've also added the capability of adding some pauses between segments. So like we just add like a 1 second pause between each segment so it doesn't feel unnatural. So there's a pause after the host speaks and the guest speaks as well. So that's what this function is all about. It's just basically combining all of this together. Now we want to set our tools to a list. So this includes our Tavily tool, our text-to-speech, and our edit post podcast audio tool. So we've set up all these tools in here, and we're also passing it to a tool executor as well. Now the next step is we want to define the model you're going to be using. Like I said, you want to use a model that supports function calling. In this case, we're going to be using Chat OpenAI's GPT-4 Turbo. This is the latest model from OpenAI, so the 0125 preview, which is GPT-4 Turbo, which was released a few weeks ago. We're setting our temperature to 0, and because we want to stream responses back, we want to set the streaming to true. Now, the next thing we want to do is to create an agent function. Now, because we're going to be creating a bunch of agents, you need to create an agent function. Now, I'm using this particular function from an existing example that I got back from LangGraph's examples. So basically, it's setting up a typical agent in Langchain. If you're familiar with that, if you're not, I would encourage you to go read up on agents in Langchain and try to build a few of them. So typically, your agent would need some kind of messaging associated with it. So whether it is your system message, your human message, and all of that, your agent needs access to tools. So we want to make sure that it has the ability to interact with the tools that we're providing to it. And also, obviously, we're importing the end and the state graph, which is going to be utilized here as well. So if you kind of look at what our agent is a prompt plus the tools. That's basically what it is. Like, so you're passing the model, the tools, and then your system message, and all of that is sort of combined together to return an agent. Now you would notice here that we're using this prompt pipe LLM.bind to bind functions function, and basically why we're doing this is we're using the Langchain expression language here. At least that's what the example was using to actually build out this particular function. So now we can go ahead and create as many agents as we want using this create agent function. Now, the next thing we need is a state. So remember what I talked about. The state is basically can be a list of all the messages or a list of all the outputs that are going to be flowing through the entire workflow. So every time a particular agent or node produces some kind of information or data, it's added to the state. So it's a log of the entire state. That's what we're kind of capturing right here. And so in this case is a message list, essentially. That's basically what it is, the message list. So now we need to kind of define our agent nodes. So we're going to be defining 4 agent nodes here. So first we want a function for our agent node. That's what we're going to define first. And then we're going to go ahead and define the particular agent we need. So we need a podcast planner agent and node. So we can create our podcast planner agent using the create agent function from earlier on. We're passing our model, we're passing the tools that this agent needs, and then a system message that controls exactly what it does. In the interest of time, I'm not going to go through every single part of this prompt, but you can take a look at it when you look at this notebook to see exactly what it's doing. It's showing exactly what is expected as an output. We want a speaker, set to host the text from the speaker, the voice that they're going to be using, and so on and so forth. So that's basically what we're doing right here. So next up is the podcast planner node. And the podcast planner node is basically combining the agent node and then the agent itself, so that when we create a node, it has all of that information it needs to execute actions. And next up, we're going to do the same thing for research agent. In this case, the research agent basically has access to Tavily. It goes to search the web essentially to provide information that is passed to the podcast planner. And then finally, we have the editor agent, which basically does some editing. You can look at the prompt here to see exactly what it's doing. And finally, we have our audio mixer agent, which has access to a text-to-speech and an edit podcast audio tool, which it can use to execute functions. So for each agent you create, you want to create a node for it as well. So that's what's going on right here. Okay, now once we're done defining our agents and their nodes, we want to define the tool node. So up until now, we've been defining agent nodes, which basically use LLMs to provide some kind of response or provide function calls that need to be made. The next thing you want to do is your tool node. And your tool node essentially just simply invokes your tools. So these tools can be your search, your edit podcast, whatever it is. And that's what this tool node is all about. So whenever we need to call that tool, we're going to use the tool node to make that call. So that's what this particular function is all about. Now, the next one is the edge logic. And now the edge logic can be talked about as a router. So it's a router that routes the next action in your flow. So if it's a function called in the last message, we want to call the tool. Call tool means that we want to invoke our tool node. So when it returns call tool, it's telling the flow, that the next thing that needs to happen now is that we need to call a tool. It takes whatever tool that needs to be called from the state and makes that call. The next one is that if it says final answer in the last message, so remember our entire agent state has this prompt that says if it's final answer, if you kind of finish solving the problem, then you want to return a final answer, and then you should be fine. So if that is the case, if it's final answer, then we want to return end, and then if none of these if this don't meet any of these conditions, we want to return continue, which will just simply continue that flow as it is. All right, so now once we're done with that, we now have to create our graph. And our graph is where you bring every single thing together. So first and foremost, you want to initialize your graph using the state graph and passing your agent state. You want to add nodes to this workflow. Now remember, we're going to add two types of nodes. They're the agent nodes, and we're also going to be adding our tool node for calling tools or invoking our tools. So here we add the 4 agent nodes that we just created. So the researcher node, the podcast planner node, the editor node, and the audio node. So we pass all 4 of them. And then we have our tool invocation node, which we're adding. So whenever there's a call tool, we know that we're supposed to be invoking this tool node function we saw earlier on. Now, we want to also define the flow between each node. So to do that, you're using conditional edges. So as an example, for the researcher, when it is at continue, they need to go to podcast planner. So whenever what they're returning is continue. So going back to kind of looking at this router, if we return continue, then we're saying we need to go to the podcast planner because that's the next step. If, on the other hand, call tool is returned, we need to call that tool. So that we need to essentially do the tool node invocation, right? Or we want to just simply end the interaction. Now, we're going to do the same thing for the podcast planner to the editor because there is some relationship there. Again, very, very similar. And also from the editor to the audio mixing agent, we want to add those conditional edges as well. And finally, for the last piece of our workflow is the audio node. Once they're done, it's an end. The moment they're done, the moment they hit continue to the next flow or next step of their flow, the next step of their flow is the end of the flow. Once the audio guys are done, then the process is ended, and the result is going to come out of it eventually. Now, the other thing we want to also define is how you transition back from a tool back to a particular agent node, because you need to always do that. So whenever you call a tool node, you need to go back to whoever it is was sending you to the tool node. So as an example, with the researcher as an example, if they send information to the tool node and say they are invoking a search using Tavily, once Tavily completes that, once the tool node completes that particular action, they need to go back to the researcher to say we're done, right? Go back to researcher, then the researcher can continue. So that's the way this actually works. And you want to define it as whoever the sender is, whoever is the person who's sending me to this tool node, I want to return back to them. I want to route back to them so that they can continue whatever they're doing. Now, finally, you want to set the entry point. So what is the first node we're going to the moment a user sends us a request? In this case, we're going to a researcher node. So that's the very first thing we're doing here. We're going to a researcher node. And then finally, you want to compile your graph, and then your graph is ready to use. So your graph can be used in multiple ways. You can either invoke your graph where it's going to run all the action and then return the final result, or you can do some kind of streaming. And we've opted to use the streaming approach here, where we're going to provide our message. So in this case, we're saying research the upcoming 2024 Super Bowl, some subplots about Pat Mahomes and Kelsey and Taylor Swift and all of that stuff. and we've basically given it our prompt. So that's what our prompt is. And we're basically streaming those responses back. So I'm going to run this. It's going to take some time to run. It's not something that's going to run immediately. It's going to take some time to run. And while it is running, we're going to be seeing the responses streaming back. So let's take a look at the responses that have been streamed back. So here we see the researcher was the very first point of entry. The researcher gets information, but the researcher immediately realizes that they need to call Tavily. So they provide these arguments to say it's a function call. What I'm being asked to do as a researcher is to simply go query Tavily using this particular information. So the moment that happens, you would notice that the next call is a call tool function, because it's gone ahead to use those function call arguments to basically invoke Tavily as a tool, basically do the search. You see it returns the URL where the search is coming from, as well as the content contained from that search. Now, you would notice that it is doing multiple searches because it's broken down the problem we've given it. We've given it to go do research about a bunch of different things. So our function said, request said research upcoming Super Bowl, and we talked about Mahomes, Kelsey, and Taylor Swift, and all of that. So it's going to go and do all of these different things. So in the very first one, it went to search about the 2024 Super Bowl. Now, the next one it's going to do is that it's going to do some search around Patrick Mahomes and so on and so forth. And as you can see, all of this content is being returned back. So the researcher is always constantly, looking at the information that is coming back and actually using it. So basically what they're doing here is when they received information from the function call, they're summarizing that information. So you can notice here, they're just summarizing the information, and they keep summarizing the information all the way to the point where they feel comfortable that everything is now completed. They have all the information they need, and then they can pass that information to the podcast planner. Now, you notice the podcast planner, what they're doing basically is generating information about the podcast, and they're passing it to the editor. The editor agrees with what's going on and says, yes, everything looks okay. And now they're passing it to the audio mix agent. And the audio mix agent now wants to use the information that has been provided to it by the editor, or allowed by the editor, to now go and call the tools, to text-to-speech tool, to continue to create the segments, the audio segments. So for each audio segment, it's creating it and it's storing that information. So it's going to create one audio, store the information, one audio, store the information. It keeps doing that until it's completely created all the audio that it needs. And you would see right here, the final thing it's doing is to now combine all the audio that has been generated. So all the segments. So you can see here, it combines all the segments is generated. So if you notice here, intro, host, guests, Las Vegas, host, asks a question about Patrick Mahomes is an MP3 file. And it looks at all these different MP3 files and combines all of them into this final episode, which is then provided as the final response. Once the workflow is ended, you see it returns end in our state, and then we have our full podcast episode generated. So let's listen to the podcast episode it generated to see exactly how it did, and then see exactly how we can move forward from here. So I'm just going to go ahead and play it right now.
Welcome to the Gridiron Spotlight, your premier podcast for all things NFL. Today, we're gearing up for the 2024 Super Bowl LLVADE, a historic showdown taking place in Las Vegas for the first time. The Kansas City Chiefs and the San Francisco 49ers are set to battle it out in what promises to be an epic clash. I'm your host, and joining me today is our NFL analyst who's here to break down the game's biggest storylines. Great to have you with us.
It's a pleasure to be here. Hosting the Super Bowl in Las Vegas is a milestone for the NFL, adding an extra layer of excitement to this year's game. Both the Chiefs and the 49ers have had remarkable journeys to get here, setting the stage for an unforgettable matchup.
Absolutely. And a big storyline heading into this game is Patrick Mahomes. He's been phenomenal, leading the Chiefs to their 4th Super Bowl in 5 years. What makes Mahomes such a standout player?
Mahomes has a unique blend of talent, vision, and creativity on the field. His ability to make plays, whether it's with his arm or his legs, sets him apart. Plus, his leadership has been key in the Chiefs' success. Another Super Bowl win could further cement his legacy among the all-time greats.
Speaking of key players, Travis Kelce's role cannot be overstated. His connection with Mahomes has been pivotal for the Chiefs' offense. How do you see this duo impacting the game?
Kelce is Mahomes' safety blanket. His ability to get open, even in tight coverage, gives Mahomes a reliable target in crucial moments. Their synergy is unmatched, and I expect them to make some big plays in the Super Bowl.
Thank you for joining us and sharing your insights. And thank you, listeners, for tuning in. Don't miss the 2024 Super Bowl, and remember to keep the Gridiron Spotlight on for all your NFL news and analysis. Until next time.
It was quite fascinating to kind of put this together, and it just simply shows the range of possibilities when it comes to what you can do with large language models, especially with these sophisticated agent frameworks that are coming out. I'm curious to see what you build when you essentially start working with LangGraph. And like I said, it sometimes might feel a little bit daunting at first, but I think the more you build applications, the more it starts to become sort of second nature to you. It definitely takes some time to get your head around it. If you do have any questions, please feel free to drop them in the chat. If you like content like this about building large language model applications, different agent frameworks, we do a video every single week, and consider giving us a like and a subscribe. Until next time, have a great one. Bye.